All right, got a classic IB style question here. Find k given that 4k and k squared minus 1 are consecutive terms of a geometric sequence. How are we going to start this one? Well, what we're going to do first of all is just make sure we know what we mean by terms in a geometric sequence. And of course, what's our definition of a geometric sequence? The ratio between consecutive terms is constant. So u2 divided by u1, or in fact the general form un plus 1 divided by un is always constant. So if these are consecutive terms of a geometric sequence, then what I can say is the second term divided by the first, k divided by 4, will be exactly the same as the third term divided by the second, k squared minus 1 divided by k. Once you've gone from the definition, it's just a matter of trying to rearrange this and solve it for what we're after. Well, I don't like having denominators if I can help it, so I'm going to multiply everything by 4k. What's going to happen there? So on the left-hand side, the 4's will cancel, and I'll just be left with k squared. And on the right-hand side, the k term is going to cancel, and I'll be left with 4k squared minus 4. So I've expanded that bracket. I've gone 4 times k squared and 4 times negative 1. You could have done it in 2 steps. That's fine either way. All right, let's get our k squareds together. I usually like to keep them positive, so I'm going to subtract k squared from each side, which means I'm going to have to add 4 to each side. So on the left-hand side, the k squared has disappeared. It's going to cancel with a negative k squared, but I've gained 4. I've got a 4 on that side from the plus 4. On the right-hand side, I've got 3k squared, because obviously 4 minus 1 leaves me with 3, and the 4's have cancelled out. Nearly there. What do I do now? That's right. We're going to divide by 3. So I've got 4 over 3 equals k squared. Now, don't fall for the trick, the trap. A lot of people who get this one wrong are going to just square root each side and have root 2, or 2 over root 3, to root 3 on 3, and they'll leave it like that. You're going to miss out on the positive and negative answer, aren't you? So although this is possible, this is not my preferred way of doing it. You can go k is equal to the positive or negative square root of 4/3. K is equal to plus or minus 2 on root 3, and if we want to be really nice and rationalize our denominator, which of course we do. How do I do that again? Just multiply by root 3 on root 3, and that would give me 2 root 3 over 3. And they'd be our answers. Let's just have a look how I would prefer you to do it. Favourite rule in maths. I've got k squared, so whenever you have a polynomial, you want to set it equal to 0. Then use some sort of factorising rule. In this case, we're excited because it's our favourite rule in maths, isn't it? K plus the square root of 4 on 3. K minus the square root of 4 on 3. Therefore, null factor law, either k equals negative 2 on root 3, or from this one, positive 2 on root 3, and of course we rationalise our denominator again, don't we? 2 root 3 on 3 from that one, which is equivalent over here to negative 2 root 3 on 3. The real trick for that one is just starting it off. This, remembering your positive and negative square root, too many people forget it, so I encourage you to always think about, oh, I've got a squared term, it's a parabola, there's 2, it's symmetric, a positive and a negative value. That'd be really good. Just check that the negative one actually makes sense in a geometric sequence. Of course it does. So there you have it. You know you got it right. All right, I hope that helps. Keep the questions coming. Bye.